In the last video, we looked at the initial setup of a material that can read from the IDMap texture and use those indices to read from a texture array. So in this video, we're going to be going through how do we set up a material that not only reads the correct index from the texture array, like so, but also handles the blending of each of those samples into the neighboring sections of the terrain. So if you like, sort of doing a linear interpolation from top to bottom, left to right, on all sides of tile. So we're going to go ahead and jump inside. In fact, we're going to go ahead and duplicate our material again. I'm going to call this mlerp for bilinear interpolation example. We're going to assign that to the landscape. With no further ado, we will jump inside. Now, in order to perform the bilinear interpolation, we're of course going to make use of this lerp node. And bilinear simply means in two directions. So that means from left to right and top to bottom. So we need to sample sort of from left to right these two corners, this dirt being this kind of dirt and this kind of grass. I'm going to blend between those two. And then this kind of dirt and this kind of grass. So we're going to get two different kinds of blending. And then also we're going to blend from top to bottom between those two. I feel like some kind of visual aid might have helped there, but we'll get to that in a minute. So we know that we're going to need some lerping. We'll call this one the top left to right. I'm going to call this one the bottom left to right. And then we're going to call this one top to bottom. So this is our bilinear lerping. It's going to be taking place. That means that we've got 1, 2, 3, 4, 5, 6 slots that need filling. These last lerp is going to use the output of the first two lerps. And then that leaves us with just 1, 2, 3, 4 slots that need filling. And each of those slots that's going to require an input pin is going to take as its input a different texture sample. So that means we're going to be sampling the array 4 times. So, which really means all that we need to do is to provide each of these texture samples with a different index. Okay, so we know that they're going to be using the same landscape coordinates and the same tiling factor. So this is going to sort of, actually, I unwired the wrong thing there. So this is going to be kind of the same for each of these here. And now all we need to do is provide a different index to the texture array. And that index is the index that we get from this index texture sample here. This is our IDMap texture. And in order to get a different index, we are of course going to have to sample this more than once. Okay, let's wire this in here, this in here, this in here. So we have possibility of blending between 4 different textures, and each of those is going to be determined by the index that we extract from our index texture, which means we just need to provide different coordinates to each of these samples. The way we can do that is we can add something to each of these coordinates. And we essentially just want to shift each of them by some factor. So let's just sort of bypass this logic for the time being. In fact, yeah, let's just look at the top left sample. That's what we can think of as this one being. If we're sort of going top left, top right, bottom left, bottom right, might be helpful to think of it in those terms. So yeah, we're not going to do any lerping yet. We're just going to be looking just at this kind of top sample up here. Go ahead and hit apply. Nothing changes. And now if I hold 2 on the keyboard and just slot in a sort of vector 2 there, wire that in to the addition. If I now add 1 in X, you're going to see that's going to shift. Oh, okay, it's not shifting anything. So that's what appears to be the problem there. So why is that not shifting? It may be because we need to just reorder these operations slightly. Okay, so the mapping scale here is set to 505. In order to achieve the same mapping scale, what I can do is I can actually put a divide after the landscape coordinates and set the mapping scale to 1. And I can set the divide to divide by 505. And what I'll also need to do then is after this addition, do that same division. Okay, so nothing's changed. But now, if I add 1 in the x-axis, we should see that that has been offset. There we go. So I need to rotate the camera. It's now offsetting that by the value that we input there. So we can get the left sample if we do -1. We can do the right sample, we do +1. And then if we zero out the x-axis and do the same process with -1, that's going to get below. And now that's going to get above. And what that means is if we were just to maybe sort of add all of these samples together, it's going to look very weird, but maybe it will illustrate the point somewhat. Yeah, doesn't really illustrate anything, just looks like a mess. But we're essentially combining those 4 samples, left, right, bottom, and top. So, and again, visualize that. Left, well, that one looks quite messy. Oh, it's because I forgot to do the divide operation. Okay, that's important. So, yeah. So now each of these texture array samples is getting the same data, just offset from itself. But if you remember, we want to sort of blend from the top left to the top right, and then the bottom left to the bottom right, and then do a top to bottom. So what we actually need to do is create that sort of top left, top right, bottom left, bottom right. So I'm going to just go ahead and name this top left, top right, bottom left, bottom right. And if you think about coordinates, sort of like how you would get to each of those points, I'm just going to open Paint. So we're going to have a square. So this is TL, TR, BL, BR. Then if this is 0, 0, that would make this -1x, 1y. This would be 1x, 1y. Then this would be -1x, -1y, and then 1x, -1y. Okay, so assuming our center coordinate is being shifted in each of these directions, then that means for the bottom left, or sorry, for the top left, that becomes -1, 1, that becomes 1, 1. Bottom left becomes -1, -1, and bottom right becomes 1, -1. Okay, so we've got all of those. And now, in order to blend from the top left to the top right, we just need to get our coordinates that are unshifted. Okay. So we're going to create a named reroute here. Named reroute. We call this grid coordinates. Okay. Grab our grid coordinates. These are 2D, so we're going to mask out the R, that is X or U, left to right. I'm going to frac, so we just want to get between 0 and 1. We can use that same value, the top left to top right, bottom left to bottom right, and then we're going to get those same grid coordinates. This time we're going to get G or Y or V, and that's going to be put in here. And if this works, it will be a miracle. Yeah, okay. So I've clearly done something wrong. We do see some kind of blending, but it's quite messed up. So in order to debug what I've done wrong here, I'm just going to look at the output of the lerp. This very first sort of top left to top right lerp. And I'm going to compare that to just if we just had the top left sample. There it is. So there's some blending happening, seemingly, but I would appear to be kind of probably too far offset. So we're getting, even in this middle one, it's being blended with a value all the way over here. So that means my offsets are too extreme. And now potentially this is where we've actually run into a pickle. I've run into a pickle because the resolution of the IDMap doesn't match the resolution of the landscape itself. So I'm just going to go ahead and set this to 500, divide by 500, which means that the IDMap resolution should now match the value. Okay, let's again have a look. All right, so what's happening? Still getting some blending, but the step distance would appear to be too large between those kinds of regions. I wouldn't expect to be getting this light colored hay kind of texture all the way over here. So just because I don't fully understand what's happening here, I'm just going to do a little 1-, see what happens. Okay, that's definitely not correct either. Oopsie daisy. Yep, so that 1- operation isn't helping. So I think the step size is too large. So I've assumed that we're taking one full step left or right. But in fact, let's try doing half-size steps, which would make sense if you were assuming that you were moving inside of a unit square. You wouldn't want to use sort of exceed a half step in each direction. Okay, and then I think as well as that, we need to offset the sort of position of these grid coordinates here by some factor. So let's try 0.5. And that's starting to look a little bit better. So let's just have a look at the source value, like so. Okay, yeah, so we've got our light hay and our sort of brown dirt, and then the output of the lerp, we should see a smooth transition. Yeah, sort of slightly shifting it to the right, the whole thing, but we're getting that smooth transition in that axis. And I believe now, if we look at our top to bottom, we should hopefully have something clean, not quite. Okay, so let's have a little look at the bottom left to bottom right. So that's looking good. But this is clearly not the same. So maybe that would make sense. Yeah, because this would be above or below. So then that leaves us with only the final lerp as the culprit. So if I do a 1 minus operation here, then you can see we now get the intended result. So as might have been evidenced by how long it took me to get that to work, I'm not really, the strongest in terms of sort of conceptualizing these things inside my head. But maybe that serves as kind of like an example of how, even if you're not the strongest sort of mathematically, with the power of the material editor and having such rich visual feedback while you're working, it's quite straightforward to sort of iteratively step yourself towards the correct solution. And in doing so, hopefully understand what's going on a little bit better. And that's basically it with regards to how we set up this bilinear shader that we're using for Pegasus. You can see that this whole shader is only 232 instructions. If I put on the shader complexity view mode, you can see it's extremely good. It's being shown as solid green. And that's not going to change according to the number of layers that you add to the texture array. You can continually add more and more layers, and you can continually add more and more IDs, up to some probably insanely high numbers. And it's not going to have any impact on your shader compilation time or your kind of iteration speed, because you don't have to import dozens of weight maps at a time. And whenever you make a change to your terrain, you're only importing one single lightweight grayscale texture. So the largest sort of portion of the work is just spent in kind of setting up and maintaining these texture arrays, and then maybe figuring out how you would extend this to support normals and other packed textures as well. But that's the core of it. You would maybe want to embed this inside of functions. Our shader for Pegasus is, of course, quite a lot larger and more complex, so we've tried to support more features, but that's really all there is to it. I guess as one last kind of little bonus for this tutorial, I'm just going to show you how we can sort of break up those different regions a little bit, sort of procedurally, so that you end up with less of that kind of obvious pixelation that kind of becomes visible as you zoom out from the terrain. So the way we can just go ahead and do that is introduce one more texture sample, and we just want to get some noise, if there is indeed such a noise texture in the engine content. So let's go and show the engine content. Click on engine. Whoopsie daisy. Let's show just textures. It's filtered by noise. So there is some. It was lying to me. I'm going to go ahead and get maybe the tiling. Any one of these noises would be good. So I'm going to go with the just tiling noise 5 here. Just going to drag that in. We're going to create another multiply. I'm going to grab these grid coordinates. Sorry, multiply those grid coordinates by a noise tiling factor. What do we do here? We set it to be 100 for the regular texture, so that's probably a fine starting point for the noise too. And of course, yeah, I need to use the divided coordinates there, like so. And then what we can do, just pull this up out of the way, is where we're currently plugging the grid coordinates directly into the ID, what we're actually going to do is going to add some factor to that. I'm going to hold Control and left click to drag from the grid coordinates out here. Now I just want to rewire this divide back into the raw grid coordinates like so. And then I'm going to plug in the grid coordinates back in here. So what we've got here is the same as before, except now the coordinates that the IDMap started using is able to be sort of modified by this add. I'm going to drag this down here. So it gets a little bit messy. You could probably tidy this up. I'm actually going to add another named reroute here. I'm going to call this perturbed coordinates. There we go, just for some clarity. And then, because I want to offset with this noise in 2 axes, I'm going to make this float 2. And I'm going to wire that noise into both. And then we can multiply the output by some factor, noise strength, lit on 1 by default. And now if we go ahead and hit apply, it doesn't look the way I want it to for the moment. Why is that? What have I missed? Hide. Let's just skip the addition for a second. Go back to the grid coordinates. That is working as expected. So why is that not working? Let's just try changing the scale. Okay, yeah. So that's definitely it. So maybe we need to grab these perturbed coordinates and use them over here instead of the grid coordinates for the interpolation. Indeed, that was it. Okay. So now, as we increase the noise strength, we can break up those sort of regions procedurally, which helps a lot, of course, with making this look more natural. And if you wanted to, you could have different noises at different scales, but I'm not going to do that now. All right, that's it. I would love to see this approach become more standardized. In the next video, we're going to look at how we kind of in Houdini can take the workflow that we created a bit further and sort of standardize it, turn it into a nice packed up digital asset, which is ready to be used across multiple projects. And then we'll sort of see where we go from there. Thanks for watching. See you in the next one.